you know, DataWeave includes built-in logging functions that help you debug and monitor transformations directly inside your DWL scripts? In this video, we'll explore different logging techniques, including debug logs, info logs, warning logs, payload logging, and logging inside iterations. Let's start with the DataWeave script structure. We are using DataWeave 2.0 and returning the output in JSON format. Next, we define a simple users array containing Alex and Stuti. This array helps demonstrate how logging behaves during loops and transformations. Now let's explore the logging functions. First, we use logInfo, which is commonly used for operational tracking, monitoring, and business-related events. Next, we log the complete payload in JSON format. To do this, we use the write function to convert the payload into a JSON string before passing it into the log function. This technique is very useful when debugging APIs because it lets you inspect the exact request or transform data flowing through the application. After that, we use logging inside a map function. For every user object in the array, we print the username using logWarn. During execution, both Alex and Stuti appear in the logs. There's also an important JSON concept highlighted in this example. We use the same key name multiple times, username. In JSON, duplicate keys are overwritten by the last occurrence, so it's always best practice to use unique field names in your transformations. Now let's move to the second script. In this example, we use the generic log function. First, we log payload, user, but the interesting part is what happens afterward. Even after logging, we continue accessing nested fields using dot notation. This works because the log function returns the original value after printing it. So after logging, we can still access friend. Name directly from the returned object. As a result, the final value becomes the friend's name. Next, we log the entire incoming request payload. After that, we use logDebug. This function is mainly intended for development and troubleshooting scenarios. In some environments, you may not notice a visible difference directly in the DataWeave output itself. However, when logs are viewed in Runtime Manager or application logs, debug level entries become extremely useful for deeper analysis. Since the official online DataWeave Playground does not provide a dedicated debug logging console like Mule runtime logs, there are some limitations. Inside the online editor, logs mainly appear as part of the execution output. There is no dedicated runtime logger panel. Advanced Mule runtime logging configurations such as log4j2, XML, logger categories, and debug level settings are not supported. The best way to fully test debug logging is by using Anypoint Studio, Code Builder, local Mule runtime. There you can enable debug level logging, configure log4j2. XML view logs directly in the console and test real Mule event payloads and variables. Example debug configuration. This enables detailed DataWeave execution logs within the Mule runtime. Even though the online editor has limitations, you can still test logging functions using log because the output is displayed during execution. I'll cover runtime level log visibility, monitoring, and API observability in more detail in an upcoming video focused on APIs and error handling. Next, we use logWarn. Warning logs are useful for highlighting important information or unexpected values during execution. Unlike debug logs, warning logs are usually easier to identify in application logging systems. This logging pattern is widely used in MuleSoft APIs for request tracing, observability, and debugging production issues. That's how logging works directly inside DataWeave transformations. Using logging functions effectively can significantly reduce debugging time in enterprise MuleSoft projects. Structured logging improves observability, monitoring, troubleshooting, and overall API maintainability. Don't forget to like, subscribe, and continue following this complete DataWeave series.